There are lines that are parallel. So let me just indicate these two are parallel. Right, so the first question says, calculate the size of the following angles giving reasons for your answers. So 8.1.1, you need to calculate the size of angle D. Okay, size of angle D. We are given BOC, this angle here, it's 110 degrees. Okay, now if you look at this angle and that angle, this is an angle at the circumference, and that's an angle at the center, and both are subtended by the same chord BC. Therefore, angle at the center is equal to 2 times the angle at the circumference. So 8.1.1, we will say B or C is equal to 2 times angle D. And our reason, angle at center is equal to 2 times angle at circumference. Right? And this is 110 degrees, and that's equal to 2D. So we divide both sides by 2, and get 55 is our D. So our D is equal to 55 degrees. Right? So our angle D is equal to 55 degrees. Alright? Then angle A is this angle. Okay? Angle A is that angle there. Now again, if you look at angle A, okay, it's an angle at the circumference. And angle D is an angle at the circumference. And both are subtended by chord BC. So we can use theorem 4. Okay? We can use theorem 4. Now we can use theorem 4, which says angles subtended by a line, which says can say angles in the same segment. If two angles on the circumference are subtended by the same line or by the same chord, then those angles will be equal. So angle A is got angle D. You can say angles in the same segment. We can also say that since this angle is subtended and that angle are both subtended by the same chord, and this angle is at the center, it means that angle A is a half of angle BOC. But I'm going to use theorem 4. Okay? I'm going to use theorem 4. So if I use theorem 4, I have to say angle A is equal to angle D, then I'll write my reasoning. Okay? It's not coming out. So 8.1.2, we said angle A is equal to angle D, and that's equal to 55 degrees. And this is because they are angles in the same segment. Okay? Then 8.1.3. 8.1.3, I said if this is 55, that's also 55. And this one here is 55. So the angle from here, that is E2, must equal 55 plus E55. Furthermore, angle G must be equal to angle B1 because they are alternate angles. So for 8.1.3, we're supposed to have angle B1 is equal to angle D, and they are both equal to 55 degrees because they are alternate angles, and AB is parallel to DC. And then in triangle ABE, okay, in triangle ABE, and our triangle ABE is this one. That's ABE, Okay, our E2 is going to be equal to angle A plus B1. So E2 is going to be equal to angle A plus angle B1. And there is the exterior angle of the triangle. So E2 is going to be equal to 55 degrees plus 55 degrees. This is equal to 110 degrees. Please make that correction. Right. So we have corrected becomes very the question becomes very easy because this angle is 55 and that's also 55. So because E2 is equal to 110 and this is 110, it becomes very easy. So we just say E2 is equal to E1, right? So our reason, we are going to use the converse of theorem 4 to prove it. Okay, because E2 is equal to E1, is equal to O1. So we have found the solution. So it's not a difficult question, just that the mistake that I made caused that. So for 8.2, we will say angle E2 is equal to angle, we look at the diagram, right? It's equal to that whole angle, which in this case is angle BOC. So I can put BOC there. So I'll put here BOC. And both are equal to what? 110 degrees. Okay? Right? Since those two are equal, then you say, therefore, BEOC is a cyclic quad. Why? We can say converse angles in the same segment. Right? Then we are done. So that's how it's 2 marks. The first mark, obviously, the first mark is going to come from having that statement. Because once you prove that there are two angles that are on the circumference, okay, in this case here, these two angles are going to be angles on the circumference. That is angle E2 and BOC, which is labeled here as O1. They are angles on the circumference. If BEOC is a cyclic quadrilateral, it means angle E2 and angle O1, they are both subtended by the same chord BC. Therefore, they are angles that are equal. Therefore, BEOC is a cyclic quad. Okay? Alright? So you get 1 mark there. Then the second mark will be